In this video, we're going to talk about how to factor some basic expressions and also how to solve quadratic equations by factoring. So let's start with simple expressions. Let's say if we have the binomial 3x plus 6. How can we factor this expression? The first thing we need to do is take out the GCF, the greatest common factor, also known as the HCF, the highest common factor. The GCF is 3. 3x divided by 3 is x. 6 divided by 3 is 2. So to factor it, it's simply 3 times x plus 2. Now let's try another example. So using the same process, factor this expression, 7x squared plus 21. So what is the greatest common factor between 7 and 21? This is going to be 7. 7x squared divided by 7 is x squared. 21 divided by 7 is 3. So we can factor it like this. It's 7 times x squared plus 3. Now let's try another example. 3x minus x squared. What is the GCF between those two, 3x and x squared? In this case, it's not a number, but it's a variable. The greatest common factor is x. 3x divided by x is simply 3. Now, if you divide x squared by x, you're going to get x. So the answer for this example is simply x times 3 minus x. Try this one. Factor the expression 4x squared plus 8x. I think my computer just kind of temporarily froze. But go ahead and try that. 4x squared plus 8x. The GCF for this one is going to be 4x. We can divide 4 and 8 by 4, and we can divide x squared and x by x. So the greatest common factor is 4x. Now 4x squared divided by 4x is x, and 8x divided by 4x is 2. So the answer for this example is 4x times x plus 2. Now let's try an example with multiple variables. 10xy plus 15xy squared. Go ahead and factor that expression. So what is the GCF between 10 and 15? Let's take it one step at a time. The greatest common factor between 10 and 15 is 5. Now, both monomials have an x variable, so we can take out an x. Now, what is the GCF between y and y squared? It's going to be the smaller of the two. It's going to be just y. Now, 10xy divided by 5xy is 2. Now, 15xy squared divided by 5xy. 15 divided by 5 is 3. X divided by x is 1. Y squared divided by y is just y. So this is the answer for this example. Here's another similar problem. 9a squared b cubed plus 12a cubed b to the fourth. Go ahead and factor this expression. Now what is the GCF between 9 and 12? The GCF between those two numbers is 3. Now what about between a squared and a cubed? It's going to be the one with the lower exponent. So it's going to be a squared. And between b cubed and b to the fourth, it's going to be b to the third. Now let's divide this by that. So 9 divided by 3 is 3. A squared divided by a squared is 1, so that's going to disappear. And b to the third divided by itself is 1. So we're just going to get a 3 here. Now 12 divided by 3 is 4. A to the third divided by a squared, you need to subtract the exponents. 3 minus 2 is 1. And b to the fourth divided by b cubed is just b. So this is the answer for this problem. Now here's another one. 27 m squared n to the fifth power plus 45 m to the 4th power n to the 3rd power. Go ahead and pause the video and try this example. So like before, we're going to take it one step at a time. What is the GCF between 27 and 45? The GCF between those two numbers is 9. Now what about between m squared and m to the 4th power? It's going to be the smaller of those two, so it's going to be m squared since it has a lower exponent. And between n to the 5th and n to the 3rd, it's going to be the one with the lower exponent, n to the 3rd. Now let's divide. 27 divided by 9 is 3. M squared divided by itself is 1, so we don't have to write that. N to the 5th divided by n cubed, 5 minus 3 is 2, so we get n squared. Now, 45 divided by 9 is 5. M to the 4th divided by m squared, 4 minus 2 is 2, so it's just m squared. And then n to the 3rd divided by itself is 1. So the answer is what we see here. This is it. Now what about this problem? X squared minus 16. How can we factor this expression? Notice that x squared and 16 are perfect squares, which means you can take the square root of each of those things. So we need to factor this using the difference of squares method. There's a formula that you want to keep in mind. A squared minus b squared is equal to a minus b times a plus b. So in this example, a squared is x squared, b squared is 16. So if that's the case, what is a and what is b? A is simply the square root of a squared. The square root of x squared is going to be x. The square root of 16 is 4. So in one factor, we're going to have a minus sign, and in the other factor, a positive sign. So this right here is the answer. It's x minus 4 times x plus 4. Now, following that same example, try these two. Y squared minus 36 and x squared minus 49. Go ahead and work on those two problems. So let's begin by putting parentheses first. The square root of y squared is y. The square root of 36 is 6. So this is going to be y plus 6 and y minus 6. Now for the second example, the square root of x squared is x. The square root of 49, that's going to be 7. So then we're just going to have a positive sign and a negative sign. So it's x plus 7 times x minus 7. Let's try some more examples. Try this one, 64 minus x squared, 100 minus y squared, and let's try 9x squared minus 25. Go ahead and try those three problems. The square root of 64 is 8, and the square root of x squared is x. So this is going to be 8 plus x times 8 minus x. For the next one, the square root of 100 is 10. The square root of y squared is y. And so we're going to have 10 plus y and 10 minus y. Now what about the third example? What is the square root of 9x squared? The square root of 9x squared is 3x. And the square root of 25 is 5. So it's going to be 3x plus 5 times 3x minus 5. Here's another two example problems you could try. 4x squared minus 81y squared. Now let's try a harder example. 16x to the 4th minus 81y to the 4th. So starting with the first one, the square root of 4x squared is going to be 2x. And the square root of 81y squared is 9y. So we have 2x plus 9y times 2x minus 9y. Now what about for the next example? The square root of 16 is 4. But what is the square root of x to the fourth? Basically, you need to divide the exponent by 2. So you'll get x squared. Now what about the square root of 81y to the fourth? That's going to be 9y squared. So we're going to have 4x squared plus 9y squared times 4x squared minus 9y squared. However, we're not quite finished. Notice that we can factor this expression. We have another difference of squares, or difference of perfect squares rather. So I'm going to rewrite the first one, and then we can factor the second one more time. The square root of 4x squared is 2x. The square root of 9y squared is 3y. So this is going to be plus and minus. So this is the final answer for the second example in its completely factored form. Now for those of you who have been watching my videos, if you like them, and if you haven't done so already, feel free to subscribe to this channel. Also, when you get a chance, you can check out this website. I'm going to post some links, and you can get access to a lot of my playlists like physics, chemistry, algebra. You can find all of that on this website, especially for those of you who might be studying for, let's say, a physics exam or a chemistry final exam. I'm going to post some links at this website where you can find help for those things. So let's get back to the video. Now, what would you do if you see a problem that looks like this? It looks like a difference of perfect squares problem, but you can't take the square root of 3 or 75. What should you do in this case? What you want to do is see if you can take out the GCF, the greatest common factor. And it turns out that we can. The GCF is 3. 3x squared divided by 3 is x squared. Negative 75 divided by 3 is negative 25. And now we can factor x squared minus 25. It's going to be x plus 5 times x minus 5. So this is the answer. For the sake of practice, let's try a similar example. Go ahead and factor this one, 18 minus 32y squared. So what is the GCF between 18 and 32? Well, for one thing, we could take out a 2. 18 divided by 2 is 9. 32 divided by 2 is 16. 9 and 16 are perfect squares. The square root of 9 is 3. The square root of 16 is 4. And the square root of y squared is y. So this is going to be 2 times 3 plus 4y times 3 minus 4y. Now let's move on to a different example. So let's say we have this trinomial, which has 3 terms. But we're going to turn it into an equation. Let's say it's equal to 0. So now we have a quadratic equation. How can we solve this quadratic equation by factoring? Notice that the leading coefficient is 1. In this situation, what you want to do is focus on the constant term. Find 2 numbers that multiply to 15 but add to the middle coefficient 8. So what 2 numbers multiply to 15 but add to 8? This is 5 and 3. 5 times 3 is 15, but 5 plus 3 is 8. So when factoring it, it's going to be x plus 5 times x plus 3. And if you want to make sure that your answer is correct, you can multiply these 2 binomials. X times x is x squared. X times 3 is 3x. 5 times x is 5x. 5 times 3 is 15. Then we'll add the 2 terms in the middle. 3x plus 5x is 8x. And so that's how you know if you have the right answer. So this is the answer that we're looking for. Well, that's how you can factor the trinomial. But now to get the answer, to actually solve the equation, we need to set each factor equal to 0. So we'll set x plus 5 equal to 0 and x plus 3 equal to 0. Now for the first equation, we're going to subtract 5 from both sides. So x is equal to negative 5. That's the first answer. For the other one, we're going to subtract both sides by 3. And so we can see that x is equal to negative 3. So that's how we can solve a quadratic equation in this form. Here's another example. X squared minus 9x plus 20. Go ahead and try that one. So let's find two numbers that multiply to 20 but add to the middle coefficient, negative 9. Well, we know that 4 times 5 is 20, and 4 plus 5 is positive 9. But if we make both numbers negative, negative 4 plus negative 5 adds up to negative 9, but still multiplies to positive 20. So to factor x squared minus 9x plus 20, it's going to be x minus 4 times x minus 5. Now let's set each factor equal to 0. So for this one, we're going to add 4. And for the other one, we're going to add 5 to both sides. So the solution for this quadratic equation is x is equal to 4 and 5. So once you get to this part, to find the answer, simply reverse the sign from negative to positive. Here's another one that you could try. X squared plus 4x is equal to 21. Go ahead and solve the quadratic equation. What do you think we need to do here in this problem? The first thing we need to do is make sure there's a 0 on the right side. So let's move the 21 from the right side to the left side. It's positive 21 on the right side, but when we move it to the left side, it's going to be negative 21. And so we want to put it in this form. That is in ax squared plus bx plus c format. So also known as standard form. So now we can factor the expression. We need two numbers that multiply to negative 21 but add to positive 4. So we know that 7 and 3 will give us 21. But in order to get positive 4, we need positive 7 and negative 3. 7 plus negative 3 is positive 4, but 7 times negative 3 is still negative 21. So to factor it, it's going to be x plus 7 times x minus 3. Now, setting each factor equal to 0, the two answers we're going to get are negative 7 and positive 3. Don't forget to reverse the signs. So these are the answers for this particular problem. X is equal to negative 7 and positive 3. Here's another one for you. 3x squared minus 72 is equal to 15x. Go ahead and try that. Now, just like before, we're going to take this term 15x and move it to the other side. It's positive on the right side, but it's going to be negative on the left side. Now we want to put it in standard form. So we're going to put the 15x between 3x squared and 72. So this is what we now have. Notice that we have a 3 in front of the x squared, so the leading coefficient is 3. When you see a number other than 1, what you want to do first is see if you can take out the GCF. Notice that 3, negative 15, and negative 72 are all divisible by 3. So the GCF is 3. So this is going to give us x squared. 15 divided by 3 is 5. 72 divided by 3 is 24. So this is what we now have. So now let's identify two numbers that multiply to negative 24 but add to negative 5. Right now we could ignore the 3. So the two numbers will be 8 and 3. 8 times 3 is 24. But we need it to add up to negative 5, so we're going to use negative 8 and positive 3. Negative 8 plus 3 is negative 5. So this will be x minus 8 times x plus 3. So the solutions are x is equal to positive 8 and x is equal to negative 3. And so that's it for this particular problem. Let's try this problem. 6x squared plus x minus 12. Now once again, the leading coefficient of this trinomial is not 1, it's a 6. However, we can't factor out 6 from x. So this problem is completely different. How can we factor this trinomial? We're not going to focus on solving a quadratic equation like we did in the last few examples. We're just going to factor this trinomial. Now for this particular example, what you need to do is you need to multiply the leading coefficient by the constant term. 6 multiplied by negative 12 is negative 72. Now, you need two numbers that multiply to negative 72, but add to the middle coefficient 1. So we know 8 times 9 is 72, and they differ by 1. Since it has to add up to positive 1, we need a positive 9 and negative 8. So our next step is to replace 1x with negative 8x plus 9x. Because if you add these two, you're going to get 1x. So we can get rid of this at this point. Now, what do you think we need to do next? We have 4 terms. Typically, when you have 4 terms, you need to do something called factor by grouping. So in the first 2 terms, we're going to take out the GCF, which is 2x. 6x squared divided by 2x is 3x. And negative 8x divided by 2x is negative 4. Now, for the next 2 terms, we're going to do the same thing. We're going to take out the GCF, which in this case is going to be 3. 9x divided by 3 is 3x. Negative 12 divided by 3 is negative 4. Now, notice that we get the same factor here. That tells us that we're on the right track. So we're going to factor out 3x minus 4 from these 2 terms. If we take out 3x minus 4 from this term, what we have left over is the 2x. And if we take it out from this term, what we have left over is a 3. So basically, what you see here goes in the second parentheses. So this is our answer. It's 3x minus 4 times 2x plus 3. Now, let's make sure that we have the right answer. Let's FOIL this expression. 3x times 2x is 6x squared. 3x times 3x is 9x. Negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12. And 9x minus 8x is x. So as you can see, it gives us our original expression, which means this is correct. Now let's try another example, one that is much harder than the previous one. Feel free to pause the video to see if you can factor this one. Now, is there any GCF that we can take out? Is there something that goes into 15, 23, and 28? 23 is a prime number, so there's no GCF that we can factor. So right now, what we need to do is multiply the leading coefficient by the constant term. So 15 times negative 28, that's going to be negative 420. So we need to find two numbers that multiply to negative 420, but add to 23. So we can make a list. We could divide 420 by 2. That's going to be 210. We can divide it by 3. That's going to be 140. And then you could just go in order. You could divide it by 4. You could divide it by 5. That's going to be 84. Now, 6 doesn't go into, actually 6 does go into 420. Now, what's the next number that we should choose? If you're ever unsure, factor these numbers. 15 is 5 times 3, so 3 and 5 goes into 420. 28 is 7 times 4, so 7 is another number that we can choose. So this is going to be negative 60. So what's the next number that we can choose? 3 times 4 will give us 12, so we could use that number. 420 divided by 12 is 35. Now, 12 and 35, they differ by 23. So since we want positive 23, let's use positive 35 and negative 12. So let's replace 23x with 35x and negative 12x. As you can see, 35 minus 12 gives us 23. Now, let's take out the GCF in the first two terms. Let's factor by grouping. So 5 goes into 15 and 35, and we can take out an x. 15x squared divided by 5x is 3x. 35x divided by 5x is 7. Now for the last two, we can take out a 4, a negative 4. Negative 12x divided by negative 4 is 3x. Negative 28 divided by negative 4 is positive 7. Next, we can factor out 3x plus 7, and we're going to be left with 5x minus 4. And so we could put that here. So this right here is the final answer for this problem. So now you know how to factor quadratic expressions and how to factor like binomials and trinomials and things like that. So that's basically it for this video. If you like it, don't forget to subscribe to this channel.